Okay, we're back on this knucklehead motor mount deal here. So I've been learning a lot of reading. Other people sending comments on what I should do and shouldn't do. So basically, V-Twin says that they use a 5/16 spacer on their front motor mount pad here. When you go from pan frame, you put a knuckle motor in it. So you're on a 5/16 spacer. People on the internet, they claim 3/8 of an inch. So that's 310 versus 375 for your height change. So the customer measured his frame. He wants 1.580. I just did my drop test here, and I have 1.545 right now and a half. So that is the distance from here to here, which is how much my cutter dropped down. That's the different height from over here. Now I put the case right here at 90 degrees. So it's at 90, right there, 90 degrees. And then I measure right over here. And we got a 0.64 degrees of tilt. So that's 5/8 of a degree. And that's assuming this is pinched flatly on here and giving a correct number. I'm not sure because we're only working off about a 5/16 area here of contact holding that on there. So it might be tilted up a little more than it should be. And when you pull down a bolt, it tends to want to put more pressure on the inside edge. It might affect it, might not. Looks like we're at 0.69 right now. So there you go. Now the cylinder decks should be (22.5 degrees). This surface is not flat, it's bouncy around here. Hear it? And we're at 22.5 degrees. That's pretty good. Let's see what this one is. 22.6, 22.5. Looks like we're at 22.5 degrees. 22.4 just went to 22. If we come off the other case half, 22.3, 4. Pretty close. I'm not sure if I got that straight. It's not straight. Gotta hold it straight to get the correct number. 22.4 still. Oop. Read it better. Alright. Now the lifter block should be the same, I would think. Make sure we're pretty straight. 22.3. The other one. 22.2. 22.3. So 22.3 is not 45 degrees. That's 44.8 degrees. Excuse me. But at 0.3, no, it's 2 off, so it's 0.6 degrees. So the lifter blocks are not at a true 45 degree angle. I don't know if that's supposed to be that way or not. Obviously, in this case, it's not. I don't know if those have been cut or not. They might have been cut. Who knows? So surprisingly, the cylinder deck comes in square, but why are the motor mount not cut square? That's kind of weird. There's 0.7 now on that. So basically, on a knuckle motor, it's designed to fit in the frame correctly, so there should be no reason to run a tilt front and back on the motor for clearance. So it should be a straight up and down motor. Back in the day, they didn't do a bunch of stupid, weird crap. They just did straight dimensioning. So if the motor sits straight in the frame sits straight to the ground, everything should be flat and true like it should be. So why is this motor mount off 0.7 degree? No, it's 0.73. Yeah, so I'm not sure what's going on there. When I cut it, we're going to be cutting flat. At least that's where I would want to cut it. So right now we were running so we're at 580 on the offset, and it's 545 what everybody says it should be. Going by the later numbers. I don't have a true motor here to measure from to know exactly what it is, because this is a used motor. So if you take the 1.99, which is what your panhead shovelhead Evo frame offset would be. Well, I don't know about Evo, but panhead and shovelhead definitely. Everybody says it's 2-inch offset between the mounts. In the Harley book, it says 1.990. It's 10 thou less. So if you take that and take 5/16 off it, you come up with 1/670. I just call it 675 and average out the number between the I use 580. It's my number. They use 590. Excuse me, not 95. I'm all screwed up. When I cut a motor mount, I usually cut them at 1.980. That's the average number I've come up in the past. I use low numbers 1.950. I don't know if I ever had 2-inch. I might have one, but usually it's 990 or 980. So if you take those numbers, you subtract off your 310, which is 5/16, you come up with your 1.670. If you average the two numbers together, you get 675. So that'd be what the offset should be. So this one here is 580 is what he says his frame is. So how do you get from 680 down to that? If you go another 16th more to a 3/8 offset plate, then that's going to take 60 thou off of that. A 16th is 62.5 thou. So if you take your 75 number and take off 65, let's call it even number, we come up with a 610. He wants another 30 thou more, 80, past the 3/8 plate. So his frame has more offset than what it should be. Right now our case has even another 40 thou, 35 thou more than that right here to get what his case currently has. So, and there's tilt built in for some reason, which it shouldn't really be in there, I don't think. So, because right now if you put this in the frame and tighten it down back here, more than likely this tilt angle is going to change the offset. You know, with the motor, different offset makes the motor tilt front to back. So it changes everything. So anyway, I don't know what's supposed to be or not supposed to be. So right now that's what this case is looking like. It's close to what his number is he wanted, but the problem is there's an angle here and it should be flat. Now the front one over here, let's see if we can actually get any kind of a number on this. And this one is 0.14. 0.18 that time. It's hard to hold it dead flat. Here's a 0.2. Let's get to a different location. Push harder, centered. We're 0.2 right there. 0.19. So it looks like we're about 0.2 of a degree off. This one's about 0.7. So it's a half a degree difference between the front mount and the rear mount. So obviously that's not very good. And that's coming off the right case, which is not the case that was really damaged super heavy. But you can see I did a lot of welding through here, but that's, yeah, this one has a big crack through. This is bad. Looks like this case, the one that's not that bad. This is the left case. I thought the right case is the one I did a lot of welding on both sides, but let's check this side here. This one's not very flat, you can hear it. There we go. 1.6, 1.3. It's not flat at all. On a different spot. Yeah, it's a little flatter right there. 0.8, less than a tenth. So this side's almost flat. So that's close enough for an error because I'm coming off of here. See, this here, you only got 1 decimal plate of accuracy. It's 0.1. When I'm going flatness, I'm going 0.01. So I got 10 times the accuracy. So if you put 8 up on that, that would be 0 over there, because it would average up to the next number up for the 10th. So basically, this case is full square to the oil pump on this one. It's flat. Our offset is not quite where we want to be, but the rear mount has got a big angle built into it, which is wrong. So I'm not sure what's going on with that. And this feels pretty flat over here. Not much different there. Alright, so anyway, what the customer wants is to put it flat. He wants an offset of 580, so that means I'm going to, without doing a bunch of cutting on the case, which I don't really want to do, I'm going to have to kick the case, we're at 45, I got to kick it down slightly to get that offset. Which will probably put about a 1/10 of a degree on the oil pump boss over there. It's going to make this angle even higher on this side. So, but when I cut it, that's going to be flat. They're both, all this stuff will be flat. The offset, no, hold on, I got to go the other direction. This needs to be taller. Which one's higher? That's low, that's high. So this has to go up, not down. So that'll make this tilt even more than what it is. So I have to bring it up a few thou. It's going to pivot up a little bit, so the motor mount's from about the same center point of the case. So probably what I do is I got to come up 30 thousandths roughly. So what I'll do is I'll hit the case until I come up to where my cutter is. I'll drop the table down half this dimension, so we got 30. I'll drop the table 15. I'll put my shim back in here, and then I'll beat the case up until it hits my cutter here, and that should give me my offset I'm looking for. Pretty close. And then I'll cut both case halves equally and see what happens. Now this one's going to be cut a little bit more because it's going to be high. So I'll have to cut a little bit. It'll probably have to cut more off that side anyway, and that side's rougher anyways, but okay. So that's probably what I do. Alright, we're back. Okay, I moved the table down to 15 thou. Which should get me close to the number I'm after, I think. I'm going to put the shim in here. Leave that alone. I think this is where I had it. So I'll go ahead and pump it up until I touch. Let me see, go back and double check. Let me double check. $5.45. So we need 80. 45. We need 40 thousandths. Or 35 thousand, I mean. 35. 45 to 35. No. 45,000, excuse me. So that'd be like 22 thou drop to get that number we need. So 22. Okay, there's 22. Now the other side's going to drop also. So it should give us half what we need. Okay, so now I'm just going to tap it up until we get to this here gets tight. So. Okay, we're touching right there. Okay, so that should get me pretty close, I'm thinking. Guess we'll find out. Go ahead and case up so it can move. That should be enough to hold it. The less pressure used to do stuff like that, the better. Okay, I'm going to go ahead and lift this up. Let's start on the other side. Okay. Go on the other side over here and set it up. Way. Okay, let's see what we got for this before we change that. We were at 7 before. .54. .54 degree down. So that's about half a degree, roughly. Alright, let's see what we got for a change over here. Should put this back up to 0. It actually dropped a little more than 1 or 2, I guess. Oh, there we go. So you drop 12 on me. We set our 0 here. Okay, so I dropped an extra 10 I don't really want. Okay, so that's a taper in there. tight on the tip, but it's loose over here. Dialed in. Yeah, quite a bit difference. I'm slowly dropping the cutter down. Oh, let me dropping the cutter down for you, dumbass. It's tight and I keep dropping, it gets tighter. What's up with that? Going the wrong direction. Alright, finally got low enough. Or high enough, I should say. Back it up half what I just went. Okay, close enough. So that's set. Back on the other side. See what we got. $5.69. So we got 2/3 of what we wanted, so I'm going to do some more. So I'm going to go ahead and play with some more and get it dialed a little bit better. The case is just sitting on a center bolt with a big hole in it, so as you move the case down, the whole case dropped on me a little bit and screwed up my number. So now I got to play around with some more. We got about 10 more thou. I got to get it back in where I need. Alright, so I'm going to come back a couple minutes.